Key skill 4 is all about circles intersecting with lines, or in the last question, circles not intersecting with lines and how you can prove that. So we're starting with a circle, x plus 2 squared plus y plus 1 squared equals 16. So this little guy would look like this. He would have a center at -2, -1, and a radius of 4, right? So 1, 2, 3. Okay, so just to get a rough sketch so you guys can visualize what this looks like. There it is. I'm going to label in my -2, -1, and this isn't obligatory, and yes, they specify that you need to sketch it, but sometimes I think it really helps to open these questions, especially if you're stuck, that you can see what it looks like. So we've been asked to find the points of intersection with the x-axis. Well, that's the x-axis here. So you can see there's going to be 2 points in our circle, here and here. Now, what people forget is that the x-axis is just a line, like any other line. And any line that is horizontal is a y-line. So the x-axis also has the equation of y is equal to 0, right? Like all of these would be y-lines. And this one happens to go through 0 here. So this would be 0, 1, 2. So it's y is equal to 0. So all you need to do is take your equation and sub in y equal to 0. That would leave us with x plus 2 squared plus y I'm going to replace with 0 plus 1 squared equals 4 squared. So, and we can keep going. So x plus 2 squared, 0 plus 1 is 1. So that'd be 1 squared equals 4 squared. So that would leave us with x plus 2 squared equals to 4 squared, which is 16. Take away the 1. So x plus 2 squared would be 15. X plus 2 squared, or x plus 2, let's just take the square root on both sides now, okay? So that would be plus or minus 15. Everyone forgets the plus or minus, okay? And if you forget one of them, you're only going to have 1 point of intersection. And you can really see that you're going to have 2 here and here. After we've taken the square root, we have the square root and the power 2 will cancel here. And that's the square root of 15. And then we move the plus 2 over to have minus 2. Depending on your question, you may or may not be allowed to leave it like that. They might be looking for a numerical value, right? So you might have minus 2 plus square root 15. So that would roughly be about 1.87, which would be probably this value here. And then the minus 1 would be minus 5.87, which would be like roughly this guy over here. It's really important to look, does your diagram make sense? Like I just made a mistake myself. And when I was looking at my diagram, I think I had an answer. I forgot to change this to minus 2, right? So I had 2 plus square root of 15. I was like, that's 5.87. So I was thinking 1, 2, 3, 4, 5. I was like, that's way out there. That doesn't look like it makes sense. So then I realized, oh, I've made a sign mistake and fixed it really easily. But it's really good to look at your diagram and think, does this number make sense in this context? I mean, your diagram's going to be a rough sketch, right? But you can sometimes see if a number looks way out. So your two points of intersection would be minus 2 plus square root 15, comma 0, because remember we made y equal to 0. And minus 2 minus square root 15, comma 0. So that would be the x and the y. Similar question, but now we're going to be doing the intersection with the y-axis. Now the y-axis is going to be here, and again, it's just a straight line, but all the vertical lines, any vertical line, will have the form x equals 2. So instead of the x-axis, we can think about that as the line x equals to 0 and do a similar technique. So we'll take the equation, but where we previously had x, we're going to replace that with 0. And so 2 squared will be 4. Bring the 4 to the 16. 16, take away the 4 would be 12. Take the square root. The square root of 12, you can think about square root 12 as 4 times 3. Remember from surds, if you need to go back, check that out, that you always want to take out a square number. So you'd have y plus 1 equals plus or minus, forget your plus or minus, guys, 2 square root 3. So y would be minus 1 plus or minus 2 square root 3. And again, to give you an idea, if I was just checking this visually, I would say, okay, the top one needs to be 2.46. Does this look roughly like 2.46? Well, yeah. And the bottom point of intersection would need to be minus 4.4 something. And again, 1, 2, 3, 4. So your diagram might not be perfect, but if you had, for example, minus 50 for an answer, you know it's going to be wrong. So you're going to write your answer as 0 because x was 0 this time. Minus 1 plus 2 square root 3. And 0, minus 1 minus 2 square root 3. If they wanted 3 significant figures or 2 decimal places, just type it into your calculator. Now we're going to get to finding the point of intersection with the line x equals to 1. So this is the line here, x equals to 1. So remember, we talked about this before. The x equal to are vertical lines. So you go to the x-axis, you go to 1, and that's what the line x equals to 1 would look like. It would be a vertical line like that. So all we do, very similar to the previous question, is we take this equation and we replace x with 1, right? So we're going to have 1 plus 2 squared. So 3 squared plus y plus 1 squared equals 16. Y plus 1 squared is 16. Take away 3 squared, which is 9. 16 take away 9 is 7. Take the square root and move the plus 1. Now your coordinates for intersection now would be 1, because remember we made x 1, minus 1 plus square root 7, and minus 1 minus square root 7. And type them in if you need the actual values. So 1.65 and minus 3.64. And again, if I'm looking at my diagram thinking, does that make sense? That would be the 1.64 I think we had, and that would be the 3.645. So the next one's a little bit different because we actually have a line with gradient, not a flat line. Refreshing back to what you learned about the line is this is x plus 5, right? So this is a diagonal line, and it's going to have a y-intercept at 5, so 1, 2, 3, 4, 5. And it's got a gradient of 1. So when I plot a line, I like to use the x equals to 0, y equals to 0 method. So if I make x equals to 0, I've got y is equal to 5, which is the point we've plotted, right? So that's 0, 5. If I make y 0, then I've got x equals to minus 5. So I have minus 5, 0. So 1, 2, 3, 4, 5. You can join those two together, and that's how you can visualize it. So you've got 2 points of intersection here and here. To find those equations, all you need to do is replace y with x plus 5, because then you'll take your equation, which is currently with 2 variables, and you'll only have 1. So this is your equation that you've got for the circle. You take the y here, and you replace it with x plus 5, because then your equation's down, we've lost a square, your equation's down from x's and y's to only x's. Okay, so that would be x plus 2 squared plus x plus 6 squared equals 16. You need to expand out both of these brackets separately. I'm going to do this fast with the binomial expansion, but you could do them manually with x plus 2, x plus 2, and multiply them out like that. Okay, then you want to collect the like terms, so 2x squared, 4x and 12x is going to be 16x, plus 4 plus 36 would be plus 40. And you always want, in a quadratic equation, you want one side to be 0. So I'm going to bring the 16 over to the other side and have it as a minus 16. So that'll leave with 2x squared plus 6x plus 24. And I'm going to simplify this by dividing all the terms by 2. So divide by 2, divide by 2, divide by 2. So now you want to factorize, you want to multiply for 12 and add for 8. So I'm going to have 6 and 2. So my two solutions would be x plus 6 equals to 0, x equals to minus 6, and x plus 2 equals to 0, so x is minus 2, which, looking at my diagram, makes sense, right? Like this would be the minus 2, this would be the minus 6. I need to find the y values too, because the question is asked for coordinates, just hasn't asked only for x values. So I go back to my y equation, which was x plus 5, and I just plug in the x's. So y equals minus 6 plus 5, y equals minus 1, y equals minus 2 plus 5, y equals 3. So the two coordinates would be minus 6 minus 1 and minus 2 comma 3. Make sure you always get your x and the y the right way around. If the algebra in question 4 was a bit rough for you, I recommend going back and rewatching the simultaneous equation videos. There's a huge overlap between this key skill and simultaneous equations, especially actually in question 5. We've been asked to prove that the circle does not intersect with a line. So we're so used to proving that things do intersect and finding the points of intersection that when they ask to show that something doesn't intersect, we don't know what to do. But actually, in reality, it starts off pretty much the same. So you take your equation of the circle, and now your equation of circles in x's and y's, and you want to have everything with only one letter. So we're going to replace y with minus x plus 6. So that would give us x plus 2 squared plus minus x plus 6 squared equals, oh, rewind, don't forget that plus 1. And again, you're just going to simplify it. And then you're going to multiply out the brackets. You're going to collect your like terms, so it's nearly identical so far. So we'll have x squared. So that would be plus 4 minus 14 minus 10x. Plus 4 plus 49 would be plus 53, and you bring your 16 over. So you want to have a 0 here. Always with quadratics. And then you want to do 53 take away 16. So 43, 37. This equation, if they do not intersect, this equation will have no solutions. I want you to go back and think about everything we learned in quadratics and the Complete the Square series. So we learned how to show that a quadratic doesn't have any solutions. And the condition was this: b squared minus 4ac has to be less than 0. And that means a quadratic has no roots. Or in this case, no roots would mean the equation that we put together to find the points of intersection can't be solved. So we would have a would be 1, b would be minus 10, and c would be 37. So b squared would be minus 10 squared minus 4 times a times 37. And the answer for that is going to be minus 4 times 37 is going to be minus 48. So because b squared minus 4ac is a negative number, 48 is less than 0, this equation has no roots, okay? Which means in this case, there are no points of intersection. We got the equation by forming a simultaneous equation that was going to give us the points of intersection, and that equation has no roots, which means there are no points of intersection. That relates back to the Quadratics and Complete the Squares series. We're going to be moving on in key skill 5 away from the equation of a circle and looking at tangents to a circle. Bye. I hope you enjoyed this. I hope you understood everything. If you have any questions, post them in the comments below and I'll try and get back to you. And I'll see you in the next key skill.